So my name is Rohan, and I have around 11 years of working industrial experience working throughout the product-based companies, mostly prominent to cybersecurities and all. So my expertise lies into the network security area where I mostly deal with the firewalls, maybe on the on-prem or on the cloud. Okay, so both. Now, that being said, what I carry is the wide range of customer knowledge base in terms of deployment, the like challenges what they really face in their day-to-day production networks and all. Okay, so my interest is in the key troubleshooting areas wherein I help my customers to fix the problem and to not only fix the problem with a temporary solution, but I also try to educate the customer at the same point so that the problem do not reoccurs no matter what the condition is. Okay, so my focus is basically on the basics. I believe to be learning on the basics concept rather than learning on the products. Now, that being said, let me talk about the batch, right? What we are going to do in here, how we are going to do in here. So this is going to be a weekend batch, which is for the NSE 4 and 7 examination, specifically for the Fortigate firewall. Okay, now we are not going to deal in FortiAnalyzer and like manager in this batch. We are only going to learn the Fortigate firewall, the security concepts linked to it in terms of the NSE 4 and 7 certifications. Now, please note the certification standards of the Fortinet has changed. Now they are offering the certification in like clubs of multi-product structure. Like, for example, if you have to earn an FCSS certificate, you have to crack NSC 7 as well as along with that you have to crack any NSC 5 or 4 in terms of the SD-WAN 40 analyzer and likewise. Okay, so that's how the certification is designed. So if anyone is having a, why I'm mentioning this point is because let's say for an example, you might be seeing that, hey, there is no NSE 4 and 7 as of now, right? But like that is not the case. If you will open the certification page, let me show you that. Let me share the screen and I will share that. Let me know once the screen is visible. Is the screen visible, guys?
Yes, Roman.
Yes,
Okay.
it is.
And I hope my audio is also clear, right?
Yes, yes.
Come on. Okay. So like for example, if I show you with reference to FCP network security, right? So this is one of the examination. There are several. So what they have done is they have clubbed several certifications in order to give you a skill-based examination. Like for example, this is a core exam and this is elective. Core means this is a mandate. You have to do it. Okay, there's no other option. It's like if you have to be an FCP in network security, you have to crack your core examination. That is a mandate, and then you have to take any one of these. Okay, so like Forti manager, administrators, or like analyzer, authenticator, or maybe for an FCP clients and all. Okay, so these are sub A exams. Now, once you have cleared both the examinations, that is one is this and the other one is any one from here, then you will be earning the FCP network security examination. Okay, so that's how it is like designed. Let me show you with reference to NSE 4 and 7 as well. Just a moment, let it load. I think this is there. That's CSS, right? Okay. So Fortinet certified solution is this list. Okay. One of the highest examination and like the certification what you can earn, and apart from that there is just an expert. Okay, so this is the top level. So with this certification, what you will find is the core examination. Look into it, NSE 7 enterprise firewall, right? So this is the Fortigate NSE 7 what we are going to cover in this batch as well. Now the same goes true for the NSE 4 also, which I showed you before. Okay, that is for the FCSS, which is one level below this. Okay, that is FCP. Okay, so like you have to crack this. This is a mandate, which is the core examination, and then you have to crack any one of this. That is your LAN edge awareness solution or the SD-WAN solutions. Okay, so that is how you will go in perspective. Now, that being said, if you will look into the it's like the all the course contents and like modules of the NSE 7, if you will scroll down, okay, so here you can see that it's like what are the topics. Like if I click on exam description there, now let the PDF load. Just give a moment. See, why I'm explaining this is because there is a lot of queries related to the certifications. Okay, so since the pattern and method has changed, so there is a misconception that NSE 4 and 7 is no longer a valid examination. Okay, so that's a wrong misconception. Now, see, these are the exam topics: system configuration, management of the firewall, profiles, security profile. That is your UTMs and all has been covered. Your routing, OSPF, and like BGP, VPN. Okay, your AD VPN is also part of that. Okay, so that is what it is. There is nothing much, right? So this many. Okay, now if you will look closely with reference to NSE 4 and 7, now I will move to my slide, okay, where I will show you quickly about the topics. Why we are saying that this batch is going to cover NSE 4 and 7 both. Why I'm saying that. Now look onto the topics in here. This is the NSE 4 examination topics. Okay, that is your introduction of your firewall. How you will do the basic configuration of your Fortigate firewalls, right? What is the concept of the security fabric? What is the concept of the firewall policies? How you have to do it, or like when you have to do it. So all things revolving around this firewall policies. Okay, netting concepts, firewall authentication concept, right? Loggings, like how, where, and how you should read the logs, event messages, debugs, packet captures. Okay, certificate of operations, as in like let's say for example, how does a firewall make a use of that, right? The certifications, and also how does a certificate plays a vital role in ensuring the security within our network? What are the use cases of the certificate? Okay, so those things will be covered into this. Now, web filtering, application control, antivirus, IPS, these are your UTM features. Okay, so we call them as in together UTM, Unified Threat Management. Okay, now you also have to cover the SSL VPN and routing as in OSPF and like BGP is static and policy based routing. Okay, so these things will be covered in here. Let me write that down as well. So it's about the static, PBR, that is policy-based routing, your BGP, and OSPF. Okay, so these concepts will be like covered. The concept of an SD-WAN will also be done, which is as a feature of the Fortigate firewall. The concept of the VTOM, site-to-site IPsec VPN, see here. The clustering concept, which is also referred as FGCP. Okay, and proxy concept in terms of inspections and all, we will be covering that. Okay, and of course, this is about the debug and packet capture. That means the way to troubleshoot the firewall. Okay, so that is what we are going to cover. Now, looking into the NSE 4 topics, if you compare with the NSE 7 here, this is the NSE 7 topics. Okay, what I just showed you on the official website also. Okay, the topics are same, right? The only difference you will see is architecture knowledge. Okay, that means you should know how your device is designed, right? Then only you will be able to work onto it. So the basic knowledge about the block structure of the firewall. Apart from that, you will find a FortiGuard, which is also a basic concept of how, like what is a FortiGuard and how does a FortiGuard ensures your device to be up to date. Okay, and like what are the features or the assistance what the firewall receive from the FortiGuard. So those things will be covered into that. Now, if you will look into Restall, this is a plus AD VPN, right? Which is nothing but an advanced form of an IPsec, which is also called as an hub and spoke, right? Restall is same, right? Yes or no? So the point is, NSE4 demands you to have the configuration, manageability, and basic troubleshooting of awareness. That is what the NSE4 is expecting from you. Okay. Whereas NSE7 expects that you should not be only proficient in configuring, managing, but you should also be proficient in troubleshooting as in terms of concepts. Let me put an example to make you understand that. For example, let's say, if you are an NSE4 level certified, it is expected from you that you know how you can block application behavior, okay? How you can optimize an application behavior. Let's say, for example, if I say that, hey, I don't want the Facebook call, video messages, and pictures to be sent on the Facebook. Rest all, everything should be working. Okay, I want that. So if you are an NSE4 certified, you would know that, okay, hey, I have to go to the application control. I have to do this. I have to apply the proxy inspection, and then this is going to work. Okay, you know where to see the logs in order to confirm whether your configuration is working as it should or not. That is NSE4 knowledge. But if you are an NSE7 certified, what it says is you should also be aware not only about the configuration, but you should know that how does application control is helping you to stop that Facebook. What is going behind the scene, right? What did the firewall look into? How did it know that, hey, this traffic is for the Facebook? It's like someone is posting a picture. Let's just stop it. How did the firewall know? Right? So you should know the backend functioning. So in short, if you will combine the NSE4 and 7, you will find that the knowledge is from basic to the top, right? So they want that you should be starting from the basics and you should go as deep as you can, knowing each and everything, how your firewall behaves, how does the feature works. Now, coming to my point, like I said in my intro as well, that I'm someone who believes in the basics concepts rather than learning in a product as specific things, right? Why I'm saying that? See, the way the UTM will work here in the Fortigate firewall means the IPS, the antivirus, the web filter, the inspection design, right? The VPNs, certificates, name it, okay? Clustering and all, whatever you name it. The way it works on the Fortigate firewall, it works on any other product. It is not that the TCP design will change for a Palo or for a Sophos or for the Forti or for the Cisco. It is not like that, right? Everyone has to follow a RFC standard mechanism. So the point is, if I know the concept, how does a cluster works? What is going behind the scene? So whether someone is asking me to work on a Fortigate or whether someone is asking me to work on any of the other vendor products, I will be confident to work on, right? The only thing I have to know is the way to move around that design. That's all. Okay. So the focus of this batch is, of course, going to be completing all the topics what I have just shown you. Okay, from the basics to the top. But my way of teaching for this batch would be to focus on the basics concept. How we are going to proceed onto this. So first of all, we will try to build the basic structure. We will try to understand the challenge first. Then we will come to understand the solution. Let's say, for an example, what was the need of a cluster? What will happen if I don't know the cluster? Let's presume that I don't have any knowledge about clustering. So what is the challenge? Once we understand that, then the solution of cluster will follow. So that will give us a foundation to know that what is the essence of clustering concept. Once we are done with that basic concepts and all, then we will try to replicate the same thing in the lab, okay, to prove what we have learned in the theory. So that will build a strong fundamental. So that's how we are going to proceed for each and every topic. So clear with that, how we are going to proceed in the batch? Okay, challenge, solution, and then lab. 3 steps, okay, for every topic. Now, next one. See, the thing is, okay, let me show you the lab quickly first. So once you enroll in the batch, I think most of you have already would have received this, whoever would have enrolled in the batch. Once you log in, right, you will, let me show you that. Close lab. Okay, now see here. This is the list of the labs what we have. Okay, I am mostly going to work on the basic lab. Okay, this is my basic topology, what I'm going to work on. Okay, as you can see, my topology is pretty simple. It is not that complex. Okay, like for example, the PC is connecting to the router is connecting to the firewall to the ISP. Okay, so that's how the simplicity is. The focus is not on the complexity. The focus is on the concepts part. Okay, if we know how does a ping work from a PC to a router or from a PC to a firewall, if there is an L3 device in between, so that concept will be applicable no matter how complex design topology you are looking at, because it will work in the same manner, right? So it's simple that we should know how does a PCA is able to ping to a PCB. That's all. Okay, so that's why my designs are very simple, and this is the lab what I'm going to use mostly for most of the concepts. Okay, but I have also separate labs for the cluster, for the routings and all, like BGP and OSPF. I have separate labs for that. Now that being said, if in case any one of you want that, hey, I want to practice on some different design, different topology, you just have to show me that. I will create it for you. Okay, because you will not be having access to create the topology structure, but I can do that for you. Okay, so like you can see, there are a lot of labs which has been created for the guys who have asked me to do that. Okay, so I will create such labs, whatever you want me to. Okay, so that's not a problem. Now, the next thing is I think everyone is aware that this is going to be a weekend batch with reference to 4 hours of class, right? From the 9 to 1. Okay, so that is going to be the timing of the batch from 9 a.m. IST in the morning till 1 p.m. That is 4 hours of the class. The frequency of the breaks and all will be decided by you guys. Okay, the mode of the communication for this batch is going to be English. If in case anyone is not able to grasp the concept in English, and if you still have some doubts and all, and if you are going to ask me to talk in any other language, my next language what I am good in is in Hindi. Okay, so I can talk in Hindi as well, but the point is that will be only if in case you are not able to grasp a concept. Okay, so but like I said, the main language for the communication in this batch is going to be English. Okay, so if you have any doubts and all, let me know, else we will proceed further. Is there any doubt?
Mohan here.
Yeah.
You know me, right? And also, can we have class till 3 hours class or something instead of 4?
See, the point is I need total hours that I need is minimum varying from 45 to 50 hours, okay, to complete the firewall itself. Okay.
Yeah.
Now, if I reduce the frequency, because like I said, that there will be a breaks and all, right? So you expect in 4 hours, 30 minutes will be gone for the breaks and all. Okay. So we only are left with 3.5 hours. Okay, so if I take 3 hours of class and there will be a break and also that
So
would
maybe we can
then the
have, if that's okay, then we can have no continuous 3 hours class, so a theory plus lab or something. But 4.5 hours something is too long when we discuss, because I experienced, so I had an issue. So I am just raising a concern here. It's not about only me. If everyone is okay, then yes, now we can. Why can't we consider 3 hours class continuously?
See, it's a call of the batch, okay? Once like batch is framed and is structured, whatever you guys will decide, I will go with that, okay? There is no harsh and force rule onto that. If you
Mhm.
guys want to have it 3 hours, it's 3 hours. If you want to guys have it for 5 hours, it's like five hours. If it's you guys, you have to take a call. But as of whatever the batches I have taken, 4 hours is something which is in a standard. But it's up to you guys. Okay, so once the batch is framed and all, then we can talk on to that. Okay, whatever you guys will take a
Yes.
call, we will follow that. Okay.
Yes, sir. Yeah. Thank you.
Okay, anything else?
Other points good. Yes.
Okay, so is there any doubt with reference to topics, the content that is going to covered in this batch? Any doubt? Okay, I see some message. Okay, there is no doubt. Fine. Okay, fine. So let's start. We'll try to cover. Let's start with a basic topic. Okay. Okay. Yes, Viru, tell me. I think there is a question from your side, right? Or it's just a hi. No, you are not audible. I cannot hear you. If you want, you can type your question in the chat as well, okay? No, okay. The question is like, is it mandatory to have an NSE4 before NSE7? The answer is no, you do not. Okay, in the Fortinet certification structure, you do not have any prerequisite as such that you have to crack NSE4 before going for NSE7 and all. No, if you want, you can directly go for FCSS. That is directly attempting NSE7. Okay, you can go for that. What is exactly a schedule of this course is? A schedule as in terms of the timing for the batch? Ronald? You are asking for timing?
Hello, sir.
Okay, so Ronald, the timing of the batch is on Saturday and Sunday, that is during the weekend time, which will start from 9 a.m. IST in the morning and is going to be lasting from 3 to 4 hours. Okay, so from like that point, so from 9 a.m. to 1 p.m. IST.
Oh, okay. Because actually I'm here in Saudi Arabia. I'm working here, so I paying the network company networking. I think this course I 9 p.m. there and then 6:30 a.m. in the Saudi Arabia.
Okay, okay.
Okay, sir. Okay, sir. Thank you.
Okay, so let's start then. Can we get the PDF of topics for which we are going to cover on this batch? Hey, Mohammed, you can directly refer to this page. Like I've showed you, right? Topics. Okay. Just I'm giving you this. You can access from here. Just navigate to the Fortinet site and you will find it. Okay. Whatever is mentioned in here, everything will be covered. Okay. Fine. So let's just start for the day. I'll share my screen. Okay, so say this. We will start with the first topic of this batch. Okay, that is a basic structure of the Fortigate firewall. Let's know what our device is. Okay. See, the point is why it is important to know the basic structure of our product is you cannot fix a broken bike if you do not know how does it function, right? How does it engine behaves? How does the fuel passes? What happens when you put up the key and try to start the engine? What is happening, right? So you cannot do some basic troubleshooting onto your bike also that, hey, my bike is not starting itself. So let's check some chop, battery point or fuel or something, right? You have to check onto that. The point is you can only do that if in case you know how the basic design of your bike is, or that applies for any other component which you are trying to fix at your home. You should know about the basic functioning of it, right? How they are designed. So since here we are going to troubleshoot the product, right? So we should also know about the basic structure of it, how it is designed. Okay, so that will help us to understand the configuration and it will also help us to decide our way to troubleshoot through the device. Okay, so let me draw a quick diagram and then I will start. And yes, since we are going to start, so one point I missed to mention regarding the queries, right? When you can ask for queries and all those things. So there is no such thing whenever something comes into your mind, speak it out. Okay, do not hold it. Okay, so if something is not making sense to you or you want me to repeat that concept, okay, whatever is triggering your mind, okay, speak that out. Fine. This is going to be your FortiOS. This is going to be your SPU, or we call it as a CPU. Okay. Now see, this box is your FortiGate firewall. I will be using the word FGT as a short form in order to represent FortiGate. Okay. Now, this box is a FortiGate firewall, which is going to be in sync with the FortiGuard. Now, what is FortiGuard? FortiGuard is a cloud-based structure, or it's a cluster of servers which is hosted on a cloud. You can think it like a data center on the cloud. Okay, so cloud is nothing but an storage unit which is hosted on some on-prem, but is or can be accessed from anywhere, right? So that is what that cloud structure is. So it's a similar kind of a thing. The main purpose of the FortiGuard is to ensure that the licensed devices of Fortinet. Now, focus on my word, please. I'm saying that the responsibility of the FortiGuard is to ensure that the licensed products of Fortinet. Fortinet is the company which makes several products. One of that is Fortigate. Okay, the other well-known products are Forti SD-WAN, Forti SIEM, Forti Analyzer, Forti Manager, Forti Auth, Forti AP, Access Point, and your Forti Switch. Okay, so these are other products of the Fortinet. Okay, so FortiGuard is responsible to ensure that all the licensed products of Fortinet are up to date in terms of databases of signature for attacks, viruses, malwares, the URL categorizations, the application categorizations. Okay, so if in case something new comes up, every moment, every second, there are millions of websites getting removed, added, modified, restructured every time, right? So whatever the change is happening over the internet, the domain level changes and all things will be replicated onto your devices. So your device you do not have to worry that, hey, if I'm trying to block a certain category, let's say you have blocked download category, okay? So you should not be worried that, hey, maybe in like future, there would be a new website which will offer some downloads. Will that be part of it? Yeah, of course that is going to be, because FortiGuard always keep on adding and updating its databases. Let me show you that. I believe my Chrome is visible to you, right? So see this. Web application security. Okay. Not this. Web solution, right? Now see here. FortiGuard has helped to stop these many malicious phishing and spam URLs, okay? And approximately we have 307 million URLs categorized. So it's a very big database. You can see since past 43 minutes, there has been 5 database released. Okay, in every database, you will see 340, something has been added or something has been modified, right? So it keeps improving your structure so that your device has all the required information in order to act as you want it to. Okay, so the functioning of the device is enhanced when it is synced up with the FortiGuard so that it is always up to date. If some attack has happened or someone has seen some virus, let's say sitting in Alaska, even if you are sitting in any part of the world, your device will learn that. Okay, so that those attacks will not impact you, because the device will know, hey, someone faced that, right? Someone saw that. So I have a full awareness about it. So if I am also getting the similar kind of traffic, I will be able to identify and say, hey, this is a virus, malware, attack, stop. Okay, so that is what it does. So it helps you to mitigate the attack surface. The attacks, the viruses, the malwares will not spread widely. Okay, so that's why there's a cloud structure. Please note, it's not only the Fortinet who is maintaining such a design, but if you will look closely, every renowned vendors do that. Whether you look in the Palo, Juniper, Cisco's, or in terms of Sophos or anything, checkpoints and all, they all have their own cloud structure, what they are using in order to keep their devices up to date. Okay, now going with that, FortiGuard is not only responsible to ensure the up-to-date database for the devices, but also FortiGuard can act as a DNS. It can act as a SMTP server in order to send the emails and all. It can act as a it can perform a similar task as a sandbox in order to give you an analysis of whether the traffic is good or bad. Okay, that can also something which the FortiGuard can do. FortiGuard can also help you to host your firewall in a DNS record. So that means DDNS feature is also supported by the FortiGuard. Okay, so what is that DDNS and all? We will talk about that when we will touch the DNS. Okay, but please note your FortiGuard is responsible to give more functions. Okay, it is not only there to just to sync the database, but it also helps you to achieve more tasks. Okay, like FortiGuard can also act as an NTP server. You do not need to host any NTP server on your platform. Okay, your FortiGuard can act as an NTP. Okay, so that is what the thing is. Now, coming to the firewall. Now see here, when the firewall is going to receive a packet, okay, whenever it does receive a packet, okay, that packet will be processed by some processes, right? That processes can be your UTM features like antivirus, IPS, web filter, or it can be your DSCP process, the process which is there to give you the functionality of this DSCP. The process can be belonging to an authentication. The process can belong to the VPN, right? That can be an IPsec VPN, SSL VPN, whatsoever, right? So every device, in order to perform a task, they are dependent upon or they are executing a process. It's same like your Windows machine. Say if you have to get a grasp of the Fortigate structure design, think of a Windows machine. The point is, let's say I have bought a new laptop. Okay, it's a fresh new laptop. Nothing is installed onto it. Now I want to install the browser, Chrome browser. Can I do that directly on the laptop? The answer is no. Why? Although I am having a certain CPU and like memory onto it, right? But still I cannot install that software. Why? Because I don't have OS, operating system. Once I have the OS, then only I can install the applications onto it. Applications in terms of processes. See here. Google Chrome is an application, but we can also call it processes, right? Because several processes for that application is running, which is helping me to browse through the network, right? See, each process is making use of CPU and memory, right? They are making use of that, correct? So the point is, these processes cannot interact with the hardware, CPU and memory without an OS. That is why here
Hello. Is this screen freeze for me only or for others as well?
I think it's for everyone.
Same
Okay.
here.
Okay. Same. Okay. Thanks.
hey guys, is everything fine now?
Yes.
Till what point I was audible? Can anyone point me to that?
Yeah. So you were saying that as we need an OS to run Chrome or other application,
Oh.
and the same way we need an OS for the yeah,
Okay.
Fortigate as well. Yeah,
Fine.
thank you.
Okay, so see, just confirm if my screen is visible.
Yes,
Screen
sir, is it visible?
Okay. Fine. Now see this. So here also the processes, right? That is your VPN process, the IKE process, the authentication process like FNB, AMD, AuthD, right? Your UTM process like IPS monitor, IPS engine, AVD process, okay? The URL monitor process, which is responsible to perform the web filtering action. Okay, so all the processes, every task is linked to a process, that there is a defined process which is going to perform a specific task. These processes needs to interact with your hardware, CPU, and memory. Okay, so in order to help the process to interact with your hardware resource, we need an OS. Without the OS, it cannot do that. So that's why you are seeing these arrows, right? So my processes are interacting with the OS, and the OS in turn is interacting with the CPU or the memory. Okay. Now, so this is how the flow works. So you receive a packet, the packet has to be processed in a certain manner, but the process which is responsible to handle that is running over the OS, which is then interacting with your CPU and like memory. Okay, so that's how it works. Now, let's talk about something more about the basic structure, because there's a doubt in here is, see, when the firewall, when the product received the packet, it would have done something, right? It would have done something. Maybe it would have checked policies, routing, or something it would have done. After checking all the things, then only he would have decided that, okay, the packet has to be sent out or it has to be dropped, right? So the main question is, what did the firewall do when it received the packet? Okay. Now that is very important to understand, because if we know that, then it will help us to decide that what is the minimum configuration that I need in order to do that. Okay, it's like to make sure that the packet has been sent out from the device or is been dropped by the device. What is the minimum thing you need to know? It will also help you to know where to start looking from. Let's say I'm saying that, hey, the customer called and said that my internet is not working. Maybe someone will say, okay, check his DNS. Maybe someone will say, hey, let's check his policies, check his routing, check his something else, right? The point is, you can start from anywhere, but who will take a call onto that? Okay, so instead of hip hopping onto that point, okay, follow some approach, right? There should be a plan that why you are looking into it. Okay, so that will be built once you know what your firewall does. Okay, now see here. I will talk about this. There is one more point that I will talk in the structure of the firewall, but after completing that life of packet concept. Okay, so the concept is called life of packet. Actually it is called first packet. That is what all matters. Okay, life of first packet. Now, why I'm saying life of first packet, I will talk that in a moment. Okay, after this. See, the whole concern is that I want to know is, if my device here is receiving a packet, my firewall received a packet and he sent it out. What did he do? He would have done something, right? That is what I want to know. So the time what the packet remains inside the device and when it leaves it, this time is called life of packet. Okay, life of packet inside the device. So see, first thing, whenever a packet is sent to a device, of course, that will be referred as an ingress interface. Packet is received on any interface will be called as incoming interface or ingress, right? So there's a packet which has been received on a interface, which is, we are calling it as an ingress. The first thing what it will do is, integrity check. Okay, integrity check. Integrity check, why does it do that? Integrity check helps to ensure that the packet what I have received has not been modified or altered in any manner. See, think like that. Someone rang to your doorbell. He said, hey, I'm from eBay and this is the parcel for you. Okay. Now, if that parcel seal is broken, the tapes and all what was put in there to seal your parcel, that is like broken. Will you accept that parcel? Maybe someone has modified something. Someone would have taken that or something, right? So the seal that was put in, that was kept on that parcel was to ensure what? That the content inside the parcel is not been modified, right? If the seal, everything is sealed and all, you go to a store, you buy a bottle, right? Or like can of a soft drink or something. Every bottle has a seal, right? If the seal is broken, will you buy that bottle, right? No, right? Why? Because you have a doubt, hey, maybe someone would have done something inside it, right? I'm like not sure. So this is not safe to drink, right? But if it is a sealed bottle, you are like going to buy that, right? So the same thing is here. The packet is traveling across the network, right? Anyone can take a capture and would have modified something and would have sent it to you. You would have no idea, right? So that's why the integrity check is done. Now, can anyone tell me what is in the packets which helps you to confirm the integrity? Anyone? What is in the
CRC.
Maybe.
sorry, what?
CRC.
ERC is in layer 2. Yes, that's correct. What is in the layer 3?
Source and destination MAC address. Oh, sorry, IP address.
No, see, every header, okay, every header. Let's start with the layer 2. Okay, I will move from layer 2, 3, 4. Okay, layer 2 header is called Ethernet header, right? See, in the Ethernet header, you will find a field called CRC checksum. Do you see this? Right? This is there to confirm the integrity of layer 2, which carries your MAC addresses. Next, IP header. It's a layer 3, right? In the layer 3, what is the major protocol? IP. So I'm talking about the IP header. See here, there is a header checksum. Do you see this? Header checksum. This confirms the integrity of the IP header. Okay. Let's talk about layer 4. What is the major protocol of layer 4? TCP and UDP, right? See, I'm using the word major protocol. I'm not saying minor protocol. If I say major protocol of layer 3, it means IP header. If I say minor protocol of layer 3, that means ICMP, ESP packet. Okay. Got it? OSPF. These are minor protocol because they are carried by IP header. Okay. So that's the difference between major and minor. Okay. So TCP is a major protocol. Now, if I look into the TCP header, here also you will find out there is something called checksum. Do you see this? Right? Now, if I look for UDP, I will show you here also there would be something called checksum and all. See this 16-bit checksum value, right? So every headers which are responsible to carry your data, okay, that may be a layer 2, layer 3, or layer 4, right? They are the only ones who are capable to carry your data, okay? So every header will have a checksum value linked to it. So whenever the device receives the packet, every device, and this concept is applicable for router, for firewall, for SD-WAN, for load balancer, for any device, even for the switches and all. Whenever they receive it, they verifies that. If the checksum value is matched with what is written in that message, we know that packet is safe. Okay, that there is no altercation, there is no, it's like no one has modified the packet. Okay, it is good and safe. Clear? So that's how the integrity is checked. Fine. So let's say the integrity of the packet has been verified and it is absolutely correct. Okay, now what? Now the next thing that your firewall will do is captive. It will check, do I have captive authentication configured? If yes, then he will ask for authentication, that hey, stop, tell me who you are. So you will be prompted for username and password. If you have not configured captive authentication, it will not ask you for that. Please note, captive authentication is optional configuration. If you have done it, then only it will check it. If you have not, it will bypass this step. Okay, so it's an optional. Please note the example of the captive authentication, although we are going to do the lab and see all that in action, but for now, just know that you might have walked into some airports, in the cafeterias, or you might have checked into some hotels and all, right? Where you would have seen there is a free Wi-Fi, right? You just have to open your Wi-Fi connection, connect to their SSIDs, and you are inside their network, right? But you might have noticed, although there is a free Wi-Fi, but you will connect and like start browsing, that is not the case, right? They will prompt you that, hey, please enter your phone number or the email ID. You will get an OTP. You will enter that, and then you are able to use that free Wi-Fi. Correct? That is called captive authentication. Okay, which is like when you are trying to connect to a network and it will ask that, hey, tell me your username and password. Okay. Now, okay, can anyone tell me, it's like I said, that when you try to connect to a Wi-Fi, it will ask you for authentication, but that is a general process, right? No matter what Wi-Fi you want to connect, every Wi-Fi will ask you for the password. So like, does it mean that that's a captive authentication? Am I saying that? The answer is no. I'm not talking about that. When you connect to a Wi-Fi, it asks you to enter the password to connect to the Wi-Fi. That is not captive portal. Captive authentication is free Wi-Fi. You have connected to the Wi-Fi is connected. But when you start browsing, you are sending some traffic, google.com, then it will ask you for username and password. That is called captive authentication. So clear with the difference? Okay. The password which is asked while connecting to a network is not captive. The password is when asked while sending a traffic, while sending a pass-through traffic, browsing Google or sending any kind of traffic. That is what is called captive authentication. Okay. Now, see the next point. Let's say the captive portal is there and you have successfully authenticated, or maybe the captive portal is not there, so it will bypass. Then what it does, after that, it will check for DNAT. The firewall will check, hey, do we have any DNAT rule which matches with the received packet? If yes, then it will modify the destination IP or the destination port. If there is no DNAT rule matching or there is no DNAT, it will bypass the system. Okay. So after, let's say the DNAT is not there, or there is a DNAT and it has done all the changes, then it will look for, what it will perform is RPF and routing lookup. RPF means reverse path forward check, and then it will perform the routing lookup. Okay, so always RPF is done first, then followed by routing lookup. Now, what is RPF? Let's understand that concept. What is RPF? See, whenever there is a packet, right, there will be a source packet, source IP, and there will be a destination IP, right, in a packet. Now, there are two types of routing lookup. If the routing lookup has been done for destination IP, routing lookup for destination IP, this type of routing lookup is called forward lookup. I think the name is itself clear, right? Why we call it forward? Because we are doing the routing lookup for destination IP to know how to send the packet in forward direction. Correct? Okay, the way ahead. So that's why we call such a routing lookup as forward lookup. Please note, if your routing lookup is done for the source IP, so routing lookup done for the source is called reverse lookup. Okay. Why we are calling it a reverse lookup? Because when there will be a reply packet, the source IP will be in the destination, right? See what I'm talking about. There is a packet with the source, let's say 10.1, who wants to go to 20.1. This is a packet. When he goes out, and when there is a response coming, the response will look like this now, that the source is 20.1 and destination is 10.1, right? That's how the reply will look like. So what was the source here? That is destination here, correct? So if I'm doing a routing lookup for source, that means it's a reverse lookup. Why? Because this will help me to know how to deal with the reply traffic in the reverse direction. Clear with the term for what is forward lookup and what is reverse lookup? Is it clear?
Yes, sir.
Yes.
Now the point is, why is the device doing a reverse lookup? Like I said, that a device will first perform reverse path forward check, right? Why it is doing the reverse lookup first? When I say RPF now, it is nothing but the reverse lookup. Okay, it is doing reverse lookup. And then he is doing forward lookup. This is forward lookup. Okay. Now, why the device is doing reverse lookup first? Please note, the firewall is doing reverse lookup in order to mitigate or stop which attack? Can anyone tell me? A spoof attack. So RPF help you to mitigate and stop spoof attack. How? Let's see. Let's presume there is a firewall which has 3 interfaces. This is port 1, this is port 2, this is port 3. Based upon that, there was a routing table. So there is a routing table of this firewall where the static entry says, hey, there is a default route and it has to be sent out via port 3. Okay, default route. Another static route says, hey, there is a network 172.16.1.0/24, which is reachable via port 2. Other static route says, hey, there is a network 192.168.1.0/24, which is reachable via port 1. Okay, there are 3 routes. Clear? Now, let's say there is a packet coming on port 1. The port 1 packet says, the packet is from the source 172.16.1.10, okay, who wants to go to 8.8.8.8. That's what the packet is. So this is the source and this is the destination. So when the packet is received on the firewall is going to do integrity check, pass. Every packet structure is good. Okay. Captive authentication, is there any captive authentication configured? No, pass. Okay. DNAT, is there a DNAT matching with this packet? No. Okay, pass. Then RPF. Hey, let's do the routing lookup for the source first, right? So first it will do for the source. 172.16.1.10. Which route it will match? This one, right? Now see the firewall. Now firewall will think, as per the routing table, the network 172.16.1.0/24 to which the source 172.16.1.10 belongs is behind where? Port 2, na? As per the routing table, this network is behind port 2. So that means the traffic from this source would have actually been coming from port 2. it should not have come from port 1, right? If the network is behind port 2, that means the source would be coming from that side. So why it is coming from port 1? So the firewall will treat it as a spoof packet. He will think that someone is trying to spoof the packet into my network, and hence he will drop it. Okay. So you will see in the debug that the packet is dropped because of reverse path check. You will see that message. Okay. So in order to, if like maybe this is a legitimate drop, or maybe you have done a misconfigured routing. Okay. So whatever the thing is, if you want that to be working, you have to allow that. So you will say that, hey, this is not actually port 2, this is actually port 1. So you have to modify your routing table to make it correct. Else, if this is the correct one, the firewall will drop it by default. Why it is doing it? Because asymmetric routing is not allowed by default. See, there might be some cases where you want such a traffic to go through, especially when you are dealing in multi-cluster DR setup, disaster recovery data centers. Okay. Or where you have MPLS and VPN kind of a setup in a DC, where also it involves multi-cluster. There, you are bound to work on a asymmetric routing. That means the packet would, if I have to go to 172.16.1.0, of course, I will go out via port 2, but the traffic from 172 would be actually be coming on the port 1. So it's called asymmetric routing. If this is something what you have to work on, in that case, you have to disable RPF check. And the way to disable the RPF check is you have to enable asymmetric routing. So as soon as you enable the asymmetric routing in the global setting, the command will go as config system global set asym route enable. Once you do that, it will stop performing the RPF check for the entire device. Please note, this is not for a specific traffic. If you enable or disable the asymmetric routing, that is going to impact your complete product device. Okay. So, and most likely you will not do that. But like I said, if in case your device is supposed to handle a asymmetric traffic, in that case, you have to disable, or you have to enable asymmetric routing. Else the firewall will keep on dropping that. Okay. Now, so is that clear? The concept of the RPF, what does it do? How does it help you to stop the spoof attack? Okay.
Once again.
Yes, please.
Once again, please explain this asymmetric.
You want to understand what? RPF or asymmetric?
Yeah, asymmetric related, you have given example.
Okay, see, asymmetric routing means asymmetric routing means, like I said, let's say there are 4 interfaces. Okay. This is port 1, this is port 2, this is port 3, this is port 4. You will have a routing table linked to every interface, right? Let's say, for example, I'm saying that, hey, 192.168.1.0/24 is reachable via port 1. I'm saying 172.16.0.0/16 is reachable via port 2. I'm saying there's a default route, which is reachable via port 3. There is one more route of 10.10.1.0/24, which is reachable via port 4, right? So in short, you are saying that these networks are behind which interfaces, correct? Okay.
Yes.
Now, ideally, what happens is if a traffic has to be, if the traffic is initiated from 192.168.1.0 network, it is bound to be received on the port 1 because that network is behind this, right? So any traffic which would be coming from 192.168.1.0/24, that will always come to port 1 as a source. Yes or no? Right?
Yes.
The same is true for your 172.16.0.0/16. The same goes true for your port 4 also, where you have 10.10.1.0/24. That means any traffic which is coming from this network would be coming on port 4. Any traffic which would be coming from this network would be coming on port 2, right? So that's how it is. Now, asymmetric routing says is the traffic, if I have to send, let's say for example, I'm saying that there is a packet, okay, with the source 192.168.1.10, destination is 172.16.1.10. This is the packet, okay? This is the source, this is the destination. So if the firewall has to send this packet out, he will always send out via port 2 because this destination is behind where? Port 2. Correct?
Yes.
Okay. But when the reply is coming, okay, see here, the reply packet will look like this: 172.16.1.10, destination 192.168.1.10, right? This is that reply packet, right? So the reply should also be received here only, coming on the port 2. But instead of that, maybe the reply would be coming from somewhere else, means like from here. This reply packet is actually coming from port 4. So that is called asymmetric routing. It should not have happened, right? This
Okay, okay.
packet with the source would have come on port 2 only. Correct? Correct, now? Because this network is behind port 2. But it will not come in that way. It will come from different interface. Maybe because of your structure, how your topology is designed. Okay, the MPLS would be sending it to someone else, or maybe because of any other reason. Okay, so if your topology requires you to have an asymmetric routing because of any means, then please make sure that asymmetric routing is enabled on the firewall. You have to do that. Else the firewall will keep on dropping this packet because he will say, hey, as per my routing lookup, this source is behind port 2. So it should not have come on port 4. Hence, I will drop it because it's a spoof packet. That is what it will keep on saying. Clear? Clear?
Yeah, clear. So there is an option, right? We can enable this as well.
Yes. But by default, asymmetric routing is disabled by default.
Okay.
So this is why your RPF is in action. If it is disabled now, you can say the RPF is enabled. Okay. So this is RPF. But if you will enable it, then the RPF will be disabled. Okay. It will not do the routing lookup for the. Clear?
Okay. In the lab, we can see that, right?
Of course. But I'm not going to show the lab right now because I've not showed you how to bring up the lab, right? So
Okay.
holding on to that. Clearing the theory part, and then again we will start from the basics. Okay. I'm just telling you what does your firewall do. Okay. All these things we will learn it again. Do not worry.
So question, if you enable asymmetric routing, is that global to all VDOMs or a VDOM specific only?
Okay, see, if you have a VDOM structure, okay, then the asymmetric routing can be enabled on per VDOM basis.
Thank you.
Okay, but if you do not have a VDOM setup, then this will be enabled for the entire root VDOM. Okay, that is for your entire device. It's a global setting. Clear?
Yes, thank you.
Okay. Now see, here, let's say the routing and all is there. If you have the routes, it will decide that, okay, hey, the packet has to be sent out via which interface. If you do not have a route, the packet will be dropped. Okay. Now, next part. After the routing lookup, what does your firewall do? It performs policy lookup. Then it will check the policy. Hey, do I have a policy which is matching with the incoming packet? If there is a match, then it will start taking the action based upon the policy action what is being configured. If it is matching policy number 1 and the policy number 1 action says accept, it will allow the traffic. If it says deny, it will drop the traffic. Okay. Now please note the policy match will happen from top to bottom approach. And how does a packet is said to be a matching with a policy? That is something we will see when we will talk about the firewall policies concept. Okay, but for now, just know that after the routing lookup, it will perform the policy lookup. If the packet is not matching with any of your policy, then it will automatically match with an implicit deny policy, which is also called policy 0. So the packet will automatically hit that and it will drop the traffic. Okay, so the default action is deny. Okay, now let's say there is a policy which says that, hey, I have to allow the packet, right? Then what it will do is it will perform NGFW action. NGFW or UTM action. NGF means next gen firewall. Please note, by definition, a device is said to be a next gen if it supports IPS functionality. Okay, if a device is capable to give you the IPS functionality, it is called NGFW. The NGFW here, what I am pointing out means inspection, that the firewall will now inspect the traffic. He will look into each and everything inside the packet, everything. Okay, and based upon what the UTM you have configured, the web filter, the IPS, the antivirus, the email filter, DNS filter, the DLPs, whatever you have configured, it will act onto that. If let's say I'm saying, hey, block the traffic for YouTube as per the web filter. Now NGFW will help the firewall to identify that, hey, this packet is going to YouTube. This belongs to YouTube. Stop it, right? So the UTM will only work if the firewall can perform inspection. So here the NGFW term represents inspection power. Remember that, okay? But when I will talk about the UTM features, maybe I think in the 3rd week of this batch, okay, there you will see that I will also prove you that without the inspection, UTM can never work. Okay, because the firewall will have no idea what type of traffic is going on. Okay, so that is what the case is. Now, if the UTM says, hey, it's good, then it will move to the next step. If the UTM says no, it has to be stopped. The traffic will be dropped then and there. Okay, even though your policy is saying to allow it, but if the UTM says drop it, it will drop. Okay, now after the UTM is done, and let's say it says that, hey, everything is fine and all, then it will perform SNAT, source natting. It will check, do I have to perform source NAT? If yes, if there is a rule which is matching with this, then it will translate your source IP or the source port if needed. If there is no SNAT action to be done, it will bypass this. Okay, so that depends upon your NATing configuration. After the SNAT, it will perform traffic shaping. Okay, traffic shaping. Traffic shaping is an optional configuration. If you have configured traffic shaping, then only it will perform it. Else, it will bypass this step. Okay, so just like captive, traffic shaping is also an optional configuration, but it will be checked at the end of the, like just before sending out the packet. It will check, do I have a traffic shaper? If yes, he will shape the traffic and send it. If not, he will send it as a normal traffic. Okay, now what is the concept of traffic shaping and all? That is a topic which we will cover after the cluster. Okay, that is maybe in the 2nd week. Okay, now after this, it will finally send the packet to the egress. Egress means outgoing interface from where your packet will be sent out. So here it was incoming and there it is out. So this is what the basic functioning of your firewall is. Now, since we know this now please note, if someone asks me that, hey, I have a new subnet added in my project, so just make a required configuration on the firewall to ensure that the traffic from that subnet newly added subnet is reaching to the internet. Let's say someone says that. So what is the minimum configuration that I need to configure? Route policy, right? And since the traffic has to leave outside, so I have to configure ASNet. 3 things. Rest all is an optional, right? I can or I cannot. See, I know it now what to do, right? Because I know what are the things the firewall will check, and where are the things where the firewall will drop it. If someone says, hey, you know what, a certain traffic is not working, okay, I will not directly jump on to check the policies or the UTMs or it's like anything like that. I will start looking from where? From my routing lookup, maybe from my captive. Okay, so now I have a approach what I can use in order to troubleshoot my product. Okay, so this is going to give you a fair amount of an idea what to do, how to look at it. Clear? And whatever the theory what I've showed you in life of the first packet, I will also prove that when I will touch the logging part. In the debugs, I will show you this. How does the firewall process the traffic? Okay, so this is very important, and you will notice me that no matter what type of configuration I'm doing or what type of troubleshooting I'm doing on the product, I will always be revising this concept. Okay, I will be using this. Okay, so by the end of the batch, every one of you would be having this in the mind, that's for sure. Okay, now see one more thing, the last thing, although I know that the class is supposed to be only for the next till this time, but can I take 10 to 20 minutes more just to add one more point in the structure? You guys are okay with that?
Yes, sir.
Fine. So see, one more thing, let's come back to this structure. Now see, your firewall, okay, follows a triple P model, parallel packet processing. Okay. Parallel packet processing says that whatever the traffic that has been received, okay, whatever the packet that has been sent to the firewall will duplicate it and it will send it to the different processes so that they can perform the action at the same time. See, the point is now, think with reference to the sales speech, okay? Let's say you are trying to sell your product, okay? That, hey, you know what, the Fortigate Firewall is one of the best and these are the Gartner leading products. You can check in the feeds and all, and you are talking them all kinds of good things about your product, okay? You're trying to sell your device. So the customer has a simple question saying that, hey, I'm okay with your device functionalities and all, and everything is fine, but just answer me one basic thing. I have a router currently, and let's say I buy your firewall. Okay, the router main function is to perform what? Let's say routing lookup. It may be performing some NATing action, maybe some policies, right? That is what the main action that it has to perform. Correct? Just give me a moment. Hey, Varun, can you make me the host? I think you have become the host because of the network flap. Make me the host.
Sure, just me. Sorry, I rarely use Zoom. So can you please just guide me how to make you host? It's a funny,
Just
but
like click on my when you will hover your cursor on my name now, you will see there is a three dot, right?
participants. Just a minute.
Yes,
Yeah, I got it now. Okay, make host. Sure. Yeah, but okay.
yeah, got it. Thank you.